ladies, this is lesson 4.4, and this is the word problem that's at the end of your note sheet. It says to use the quadratic equation as a model. So again, we'll have to, find our area and come up with a length and a width, and we're going to have a variable in that equation for in our area formula. We're going to have a variable. So it says that we're designing a garden for the grounds of DSHA, and you want the garden to be made up of a rectangular flower bed. So we know it's going to be rectangular, and it's going to be surrounded by a border of uniform width to be covered with decorative stones. So I'm just going to start by drawing a picture, like you should for all these kinds of word problems. So here's my flower bed. And it says that my flower bed is 22 feet by 15 feet. And it says that I want to cover my flower bed with a uniform width decorative stones. Okay, so on the outside of my flower bed is going to be my decorative stones. And since it says uniform width, I know that this distance and this distance are going to be the same, so I can call those x. It says that my budget's going to allow for enough stone to cover 120 square feet. What should the width of the border be? Well, if I'm looking just for the width of the border, so let's make that the blue. All right, I'm just looking for this. Okay, I'm not looking for the whole thing. I'm only looking for the width of the border of my flower bed. So I don't have a perfect formula to come up with that area just of the flower bed. So I need to take the area of the whole thing, the flower bed and the border, and subtract the area of the flower bed, which is this. All right, so what's my area of the flower bed? Just the flower bed, just that purple region? That's going to be 15 times 22. Okay, so that's my length times my width. That equals 330 feet squared. All right, so my area of the flower bed equals 330 feet squared. Now, what's my area of the whole thing, the flower bed and the border? So that's my flower bed and my border. Well, it's going to be length times width, which is this whole length. So this is 22 feet from here to here, but then I have an X on each side, okay, because that's my uniform border is the width X. So that makes my length 2x plus 22 times my width, which is here's my width, 15 feet of the flower bed, but that's just from here to here. And then I have an X on both sides. So that's 2x plus 15. All right, right, so that's my area of the whole thing. Now, what I really care about is just my width of the border, because I have a budget for 120 square feet for stones that are only going around my border. Okay, so now, how do I find that area of the border? I'm going to take the area of the whole thing minus the area of the flower bed. So my area of the border equals the area of the whole thing minus the area of the flower bed. All right, so my area of the whole thing is 2x plus 22 times 2x plus 15. That's the area of the whole thing. And then I'm going to subtract my area of the flower bed. Which is 330. And that's going to give me my area just of the border. And I have enough for 120, I have enough in my budget for 120 feet squared. All right, so if I rewrite this, I have 2x plus 22, that's my length of the whole thing, times 2x plus 15, that's my width of the whole thing. I'm going to subtract the area of the flower bed, and that's going to give me my maximum area of my border. I'm going to use my whole budget. All right, so now we have our equation. So now we need to solve for x, because it's asking us to find the width of the border. That's what we're looking for, the width of the border, which is x. Okay, so we want to solve for x. So our first step in solving for x is set the equation equal to 0. Next, we'll factor. Next, we'll use the zero product property. And then lastly, we'll solve for x, or whatever our variable ends up to be. All right, so the first thing we want to do is use FOIL to get this all in standard form so that we can combine like terms and then set our equation equal to 0. Okay, so if we FOIL, we've got 4x squared plus 30x plus 44x plus 330 minus 330 from here equals 120. So now let's just combine our like terms. So that gives us 4x squared plus 77x plus 0 equals 120. Now we need to set our equation equal to 0. So we're going to subtract 120 from both sides, and we get 4x squared. Oops, this should be 74x. We get 4x squared plus 74x minus 120 equals 0. Now we need to factor, and we're going to factor our a term, and we're going to factor our C term. Now, since 74 is not divisible by 4, again, we don't want to just factor out 2, because that's not one of our full monomial terms, and it could lead us to believe that this is non-factorable beyond that. So when you're factoring out a common monomial, only do it for the full monomial term, which, again, since 74 is not divisible by 4, we cannot do for this particular problem. So let's try a couple different things. Factors of 4 are 2 and 2, and we want something that adds up to 74. So here's our A terms, here's our C terms. So we could have 2 and 2 here, and then, I don't know, just for practice, we could do negative 12 and 10. So 2 times 2 is 4, negative 12 and negative 10 is 120, so that part works out. But 2 times 10 is 20, minus 24, that does not add up to 74. Okay, so that's not going to work. So let's try a different one. And this is if you're sticking with 2 and 2. Again, there's more than one way to do this, but so here's our A term, 2 and 2. And let's try, I don't know, factors of 12 are 3 and 4. So we could do like 3 and negative 40, or vice versa, negative 3 and 40. Let's see if that works. So 2 times negative, there, let's see. 2 times 2 is 4. Negative 3 times 40 is negative 120. So those won't work. 2 times 40 is 80. 2 times negative 3 is negative 6. So 80 minus 6 is 74. So that one works. All right, so now we set this up. So what did we say? This was negative 3 and 40. So again, anytime I set these up, set up my groups first. So I've got 2x and 2x, and I multiplied 2 and 40 together. Oops, that's plus 40. And I multiplied 2 and negative 3 together. So those go in opposite groups. So this will work for factoring. And again, just to double check, you can always go back and use FOIL. So 2 times 2, that's 4x squared plus 80x minus 6x minus 120. So 4x squared plus 74x minus 120. That's what we want. Okay, so now our next step after we factor is to use the zero product property. So we set equal to 0, we factored. Now we're going to use the zero product property to solve for x. So the zero product property says that either this equals 0 or this equals 0. So either 2x minus 3 equals 0 or 2x plus 40 equals 0. So we're going to use that property to solve for x. So 2x equals 3, x equals 3 halves. So that's one value for x, or 2x equals negative 40, So x equals -20. That's another possibility for x. But again, in the context of this problem, x cannot equal -20 because x is the width. So this distance here cannot be negative dimensions. So our only option then is that x equals 3/2. So that is your solution, x equals 3/2. So please jot down any questions you have. This should help you with the story problems for your homework. And you can ask when we get together in class. Thank you.